All right. Well, first of all, I wanted to thank the Mad Pass group. It was exciting to get the quick LinkedIn message, asking us to step in and really perform kind of an education for the group here. We did put together an agenda, with Century and Exact Sciences both being customers, but individuals that may not have been as familiar with Snowflake as other folks we work with. This will be a great way just to kind of level set, give you the understanding of why, as an organization, both Century and Exact are very excited to be working with Snowflake. But then really what we want to do is pivot into letting Brian explain what really separates us and what differentiates us in the market and when to think about Snowflake for analytical needs. And he'll be able to walk us through that. I doubt we'll need the full hour, but please, stop us if there's any questions, comments, or concerns. Let's keep this interactive. So just a little bit of background, Lang, you coming from California, that's where our roots are based as well. So, Snowflake was founded in 2012. The unique thing about Snowflake is, we are not a organization that was spawned out of, open source or anything like that. Our founding architects, our founders were actually two of the technical architects for Oracle. So these were longtime database individuals, been working on the Exadata platform for years, hundreds of patents between the two. And what they started to see in the late 2000s was that there was a change coming, and that change was public cloud. And what they saw was all of the code and the legacy, that IP that they'd built into Oracle, for them to take that and be able to move that forward into the cloud-based economy that was coming, they didn't think they could keep all of that on-premises, lineology and move that forward. So they decided, instead of trying to retrofit Oracle, move it to the cloud, they decided, hey, we're going to go do this thing ourselves. And we're going to burn the boats behind of legacy architecture. We're going to build this from the ground up to take full advantage of the cloud elasticity and scale, the on-demand performance, delivered as a service, and finally deliver a analytic service for customers that could be consumed by the byte, not on a huge 3-year, hardware spend like contract. And you fast forward to 2020, and Brian and I have been here for 2 years each now, and the results don't lie. We've got over 30 customers here in the state of Wisconsin, but we've got north of 4,000 customers globally. Everyone from the small startup that's trying to build their business in a different way than they ever have been able to in the past, through the Fortune 5 and Fortune 10 spending tens of millions of dollars with Snowflake. So it really is a one-size-fits-any model with Snowflake, and we look forward to sharing that with you. So it's been a pretty wild 6 months for us, on top of the fact that we've been a pretty fast rising software company. We actually are one of the fastest growing software companies in the history of enterprise software. We are private. There's been no shortage of news trying to figure out when we're going to go public. I don't have any updates or news for you guys here today. But the impending news looks to be that it's going to happen sometime in the next year to a year and a half. But mixed in there's been some really interesting things that as a company we've also decided to do. So our CEO comes by way of ServiceNow, another monster in the software space. He has a huge belief of content coming onto our platform. So one of the first things he wanted to do was sign a strategic partnership with Salesforce, and they did that by way of an investment in us. And the cool thing for anyone that uses Salesforce today, their long-term strategy is that they want to make any data inside of Salesforce now backed on top of Snowflake. They want to be able to have that data shared instantly, live, governed access without ever having to run ETL across their entire data set. It's an incredibly powerful message. And that's just the start, Adobe, ServiceNow, Workday, you name it, we're in these discussions. We want to bring data to the platform, get it close to end users like yourself. And that's ultimately what we're calling our data cloud. And we'll be going through that here in the very near future. So when you look at Snowflake, Brian and I, when we started, there was a handful of customers in the state. We're very proud that we have customers big and small across the entire state here. When you start to look at, Capital One doing, all of their lines of business running their application sets on Snowflake, Adobe moving their campaign manager software to now have that same look and feel of live data sharing that we're talking about with Salesforce. McKesson, right, one of the Fortune 10, they're building healthcare applications and analytics and actually providing those back to their customers. And then organizations like Nielsen, when we talk about this data marketplace and encouraging data providers to bring their assets onto our platform so customers like yourselves can get live direct access to what they have to offer. Nielsen's the grandfather of data brokerage services to begin with. And actually, they're a funny one because Brian and I have actually gotten calls from prospective customers that have said, hey, we spend millions of dollars with Nielsen. They have told us, hey, instead of us sending you an FTP file, you're going to consume your data from now on through Snowflake. So we're really excited about all of these major partners that we work with, but we're even more proud about the companies here in the state, and 2 of them are represented on the call today. So thank you both.
A way to think about that is instead of having Nielsen FTP you a file and you have to mess around with it, you're effectively now outsourcing the ETL to them, and they're sharing an analysis-ready database with you, which is cool.
And then finally, everyone, there's no shortage of time. There's no shortage of meetings that one can have. So anytime we get into an audience like this, we want to be blunt and transparent. As an organization who is either looking at Snowflake, has or has not yet looked at but would consider Snowflake, we really try to make it as simple as possible. It's our belief that organizations that are successful customers of us have found benefits in these 3 main pillars. First and foremost, we want to make the experience easier, faster, and we want it to be a scalable architecture that you can roll out to your enterprise. When we talk about instantly production ready, there is no software to install. You're not going out to Azure, requesting a VM, installing operating system software, working with, various different teams to set that up. With Snowflake, it's a managed service. We provision all that for you. So it's incredibly powerful when you start thinking about how quickly one could stand this up. As we mentioned, this is delivered as a SaaS service. So it's pure software as a service play. But the coolest thing about Snowflake is we run one version of our code. Whether you're, running one server cluster or, 10,000 server clusters, it's one set of code to manage. So a lot of our developer customers are really happy because it makes implementing software that much easier when you have one thing to manage and workload. Another part that we're going to talk about is workload isolation. Being able to extract compute away from storage, away from the services layer, allows you to be incredibly dynamic in how you run the solution. And then finally, no one wants to pay more money for anything, right? We've yet to have a meeting where we have more budget to go after. So we always tell customers with Snowflake, this is a true cost model. We're going to help you on infrastructure and also your operational savings because you're doing more with less, and there's less time spent with the tasks that behind the scenes we're delivering to our customers. You pay for what you use. And at the end of the day, customers want to receive and acknowledge the value faster with Snowflake. And that's what we try to do for any prospective customer that we work with.
So I guess over to me. I live in Madison. I've been at Snowflake for 2 years. Worked a bunch of other database companies, Cloudera for the last 5 years before this, pushing the Hadoop stuff. So know a lot about databases and BI tools. I guess I'll ask you to think about what your database was doing in 1987. If we're talking about SQL Server, the roots of today's SQL Server, was Sybase, and that code was in 1987 was around. In fact, every production database except Snowflake arguably has its roots in 1987, old school on-premise technology. And that's fine, but when you move to the cloud, it's good to redo things. And here's just an example why. If you look at a traditional architecture, you might say, okay, I'm going to buy SQL Server and I'm going to put my sales data on it. I'm going to use another different SQL Server for my finance data and one for manufacturing. But then the sales guys want some finance data, finance guys reciprocate and ask for sales data. Pretty soon you've got a lot of jobs moving data around. And in Snowflake, we've got a big enough architecture where you've got shared data. You've got endless compute you can spin up, and you only pay for it when you're using it. And every query that uses compute can hit any table in Snowflake that you want it to use. So there's no more silos. It's separation of compute from storage. And whether you're Land's End or Capital One, all your data can fit in one Snowflake system. And sometimes my customer's biggest worry now is recreating logical silos, with our role-based authentication. So they make sure people see the subset of data that they want, because by default, everyone could see everything, even if you've got 100 petabytes and 1 million different tables. So what we tried to do is Snowflake was invented in 2012. That's when our company started. We started selling it in 2016. Now, 4 years later, we're doing pretty well. It's hard to build a database. Our founders were from Oracle. They were the guys that invented Exadata. So they know how to build a database. But they said, hey, if we're going to go to the cloud, this thing really needs to be built from the ground up. We can't just take Oracle and move it to the cloud. It needs to be different. And so this is really data warehousing for everyone, where we've got separation of compute and storage. We've got instant scalability, and it's built as a service. So there's not a lot of tuning, not a lot of messing around. Yet you still get out of the box performance that's better than, generally better than what you have. I can say when people have tried Snowflake in Wisconsin, I've not lost a proof of concept yet. We've always been faster. People have always chosen Snowflake. And it's a little bit like we've got an unfair advantage, right? Because we built this thing for the cloud. We don't have the legacy code risk constraints. People like that they're not tuning knobs. With Oracle, someone told me once there were 25,000 init Aura parameters, just decisions you could make when you started Oracle up. We don't have any of that, yet we run pretty fast, and you can run us on the public cloud of your choice. So it sounds like we're a new thing, but we've got a lot of familiar stuff. We've got tables, columns, rows, views. In fact, you can migrate from SQL Server to us with very little changes. Maybe your hardest thing would be if you had a bunch of T-SQL stored procedures, you'd have to modify those and change them over to our stored procedure languages. We've got the role-based security. We work really well with the Microsoft environment. We're one of Microsoft's 10 biggest customers in North America because a lot of people run us on Microsoft Azure, and we have to pay the Azure bill. So about 30 to 40% of the money customers give us goes to either Microsoft, Amazon, or Google. We tie in with Active Directory. If you're using Power BI or other BI tools, we've got single sign-on. We are ACID compliant database, but we're not claiming to do fast transactions. The one thing I would not use Snowflake for is an OLTP application database. But it is cool that, if you do a single row insert, we're going to treat that in an ACID compliant fashion. We've got full SQL. I've not run into anything I couldn't do in SQL Server that I can't do in Snowflake. And a lot of your table DDL and SQL is really relatively unchanged. There's very few syntactical differences. We've got ODBC and JDBC, so all the tools talk to us. And we're an MPP database, so we've got multiple servers working on your query at one time, and you can tell us by a t-shirt size. A small t-shirt size cluster is 2 servers, and extra large is 16 servers, and we go all the way up to 6XL, which is 512 servers. And so things get linearly faster if you've got big data. The bigger the t-shirt size you choose, the faster your stuff runs. We've got migration manuals out on the web. The Azure Data Warehouse SQL Server migration manual isn't out there because Microsoft's our friend, so we don't put that up there. But we've got the Oracle and the Netezza ones, and we share the one privately with SQL Server people. But Teradata is a really hard thing to migrate to. When I worked at Netezza, we had a tough time getting Teradata customers to migrate. Same thing when I was at Cloudera. The Sentry folks did a Teradata migration, and they did a lot of it without even calling us. When Travis and I had our first sales call at Sentry Insurance, they told us they'd been using Snowflake for 6 months, just paying for it on demand, $3 an hour with a credit card. And they'd already figured out that they could migrate Teradata without ever talking to us. So I thought that was pretty cool. And then their Teradata migration was successful. So data warehouse as a service, elastic, best price performance. I do a lot of POCs against Azure, SQL DW, and Redshift. And I was telling folks before we started, we're generally 3 times cheaper, and some are like 5 to 10 times faster on average. I would say on smaller data, SQL Server can beat us on that. If you've got a 10,000 row table, we're not going to give you any real benefit. But you get into the millions of rows, and that's where we start to shine with our parallel environment. In terms of tools, Power BI, any BI tool you can find works on us. All the different analytic frameworks, all the ETL tools. We even got customers like CUNA Mutual and Madison has SSIS loading us. So a little bit about our architecture. Maybe the biggest difference is that we've got a cloud services layer that's always on, that's completely separate from what you're paying for. And so if you're paying us nothing, you haven't even started up a cluster, if you run a query, that query goes to our cloud services layer. And we plan it, and we decide if we need to turn your compute on. If you've run a query in the last 24 hours that we've already seen and your data hasn't changed, cloud services will just say, I saved the answer. Someone else ran that thing 20 minutes ago. Your query is identical. Here's the answer. And so this is like a dial tone. And this is why when you shut down Snowflake, we don't lose our mind. If you think about it, with Azure SQL DW, SQL Server, its brain is part of its cluster. So when you shut it down, its metadata is gone, its brain is off. Our metadata is living in a big NoSQL database out in the cloud. We've got metadata servers always running that you don't pay for. We're always ready to take a query, whether you need, whether you're paying for a compute or not. And now when you do decide to size your compute, you say, hey, I'm going to sign up for one of these t-shirt clusters, and I'm only going to pay for it by the second. And much like a motion sensor light, I want the thing to shut off if I'm not using it. So I'm going to put a 5-minute timeout on it. And these are just stateless workers, if you will. They don't have any metadata on them. They don't know a lot about your database, but we send them work and they talk to the storage layer. And what they're talking to in the storage layer is just blob storage. We're just using Azure blob storage, Amazon blob storage. It's about $5 a raw terabyte per month. You know, I've got customers in Wisconsin with 80 terabyte databases, and they're only paying a couple $1,000s a year for storage. Storage is so cheap these days, you really don't need to talk about it. And we do store data in a compressed format, a columnar format. It's similar to Parquet, if you know that, although it's a little bit different. It's proprietary. We get about 10x compression very often. And so this is what the whole thing looks like. I've got cloud services. That's my system brain. That's my dial tone. It's managing the infrastructure security. And then when we do fire up a warehouse, you know, if any of you ever fired up Azure SQL DW, it takes 5 to 10 minutes because you've got to procure AMIs or virtual machines, and you've got to install Azure SQL DW and kind of build your cluster. In Snowflake, you see that little Snowflake compute pool off to the side? Since we're a multi-tenant system, you're all running in our Snowflake system, we've got thousands of servers just waiting for you to use. So when a user submits a query to cloud services, we can attach that 16-node extra large cluster to your system, usually in less than 2 seconds, and boom, your query is running. And then when your query times out or your system times out and it says, hey, no one's run a query for 10 minutes, shut it off, we just put your compute back in the pool and you stop paying for it. And then we're all just talking the same blob storage you might be using for your own data lake. Now that I've showed the architecture, any questions from the audience? Giving people time to stumble for their mute button.
Yeah, say Brian.
Yeah.
This is Dennis from Century Insurance. Anyway, I do have to leave, and I didn't want to impolitely just cut out, but I will say, you know, the Snowflake for us has been really a very good experience. I mean, there's a lot of, from a SQL Server perspective, there's a lot of cool things that are different. You know, I like the idea of separating the database from the warehouse. You know, the time travel, the query histories, all that stuff. You know, it's kind of a little bit of a different mindset, but for the most part, you know, it's pretty much an easy transition into SQL because, you know, the language and all is the same. But actually having worked with it a little bit, you know, this is kind of high level, and I'm going to cut out and fire up the grill because it's a beautiful day here. All right.
Well, thanks,
Thank you very much.
Thanks, Dennis.
All right. Bye-bye.
Yeah, that was a nice testimonial from Dennis. And with time travel, what he's talking about is the data storage layer is so cheap that we store 24 hours of your query results. And so if someone sends us a query we've seen before, even if it's a 10-minute query, we can get the result to you in less than a half a second. and we don't charge you for that even. You don't need to use a virtual warehouse. You don't actually use our compute. So that's cool. And then we keep up to 90 days of all your table changes. So if you update a table, we say, hey, I've got a block called a micro partition and you just changed it. So I'm going to, instead of deleting that, I'm going to give it an expired date. And it's now got an effective date and an expired date. And our cloud services layer can put together a picture of your table as of the current millisecond or any millisecond in the last 90 days. And so I can just say, run this query as of last Thursday at noon, and I'll get that answer. And so that's a cool thing, that the cost of storage being cheap and, cloud services up in the cloud have made very easy to do. And here's the time travel for data, right? I can clone a table, I can undrop a table, I can say create table as, select star from the table that's gone now, but as of last Thursday, and boom, I've got that table back. And so people are making a journey to a cloud data platform. I've got people that, have an on-premises EDW. I was just talking to a customer that's got DB2, and I remember when I worked with Tammy back at Land's End, we had one of the first DB2 data warehouses, and that's how I kind of got started my career in the early 90s with data warehousing. My last job was with Cloudera for 5 years selling Hadoop. That seems to be falling out of favor because it's too complex. It's like you're looking at the dashboard of a 747 when you're using it. There's a whole bunch of first generation cloud vendors, and I would say that's like Redshift and Azure SQL DW. Azure SQL DW is effectively a wrapper around SQL Server 2016. It's got multiple copies of SQL Server 2016, and they've each got their own brain. And one of the difficulties Azure SQL DW has is if you've got two databases on the same platform, you can't have one SQL statement query both databases. And of course, in Snowflake, we don't have that kind of silo. Any query can query any database and schema on the platform. And that's why eventually we're telling people, hey, you need to get to a database in the cloud that's designed for the cloud. And we understand, Microsoft is the new Synapse they're talking about. That's on a 3-year journey to be architected just like Snowflake. Redshift's doing the same thing. So both of them have said, in the next 3 years, we're going to have a cloud services brain just like Snowflake does, and we're going to match them on some of the features. But we're doing that now. So here's what it looks like, and we're identical regardless of the cloud you run on. So we've got people using us as a data lake, people doing data engineering, all kinds of neat things. And it's really hard to tell what cloud you're running Snowflake on because it's the same everywhere. And here's what it might look like in practice. I've got my cloud services. I've got my data replicated in triplicate in, say, an Azure or Amazon region. I've got a set of virtual warehouses, different size t-shirt compute. And maybe I just need an extra small one to run my ETL. I've got Informatica or Azure Data Factory feeding that. I've got a warehouse that every time Azure Data Factory sends it some data, it processes it and puts it into Snowflake. And Azure Data Factory might be doing push down SQL. That's the processing that's happening. At the same time, you can just dump the data in your own Azure Blob Storage. And we've got a serverless utility called Snowpipe that'll look at Azure Blob Storage. And every time it sees a file, it'll eat it. And so that's kind of cool because I don't even really need an ETL tool. I just need to be able to dump data into Azure and Snowflake will eat it. Then at the same time, our average customer has a different compute virtual warehouse cluster for every group. So sales might have their own, the data scientists might have their own, marketing might have their own, because it's very easy to right size them. And since they turn off when you're not using them, when smaller groups use them, they're just off more. And so here's an interesting thing. Say the data science guys need to run a bigger job. In less than 2 seconds, they can ask for compute from the pool and make that cluster 8 times bigger. I've seen with Azure SQL DW, that's a 5-minute outage. You've got to stop all the existing queries, and 5 minutes later, you can use the system. With Snowflake, there's no interruption. Same thing with sales. If on Monday morning or the end of the month, there's a lot of people using us, we'll automatically add another t-shirt size cluster to double our concurrency. So say that first medium cluster could run 12 concurrent queries. Boom, now we can run 24 queries. Now we can run 36 queries. The scaling of one node determines how fast you want to run a query, and we let you handle that manually. But the concurrency scaling you can make happen automatically. Because basically we don't want things backing up. If queries are queuing, we'll get rid of the queue if you tell us to. We can eat XML, JSON data, also Parquet and Avro, so anything semi-structured. We can automatically just dump your XML file into a one-column Snowflake table, and we can parse that and make it look like a flattened table. That's a real popular thing with us. When it comes to development, you don't need to have a separate development Snowflake system. We can make a logical clone of your production database and give your development guys their own warehouse. So now they're totally isolated. They're working on a logical copy of your data. They can update it without changing anything, and they've got their own compute. And if you've got a 10 terabyte data warehouse, it takes like 5 minutes to give them a full logical copy of that 10 terabytes. So one thing my customers like best is giving their developers a fresh copy of production every morning. Quick and easy. And then they can mess it up without messing anything up in production. And then since we're a multi-tenant system, if there's another customer in your region that you want to share data with, you can automatically share your database real time with them. So when AC Nielsen shares data with Kimberly Clark, the Kimberly Clark guys are effectively querying AC Nielsen's table. And really it's a view of the table. But if AC Nielsen inserts a row, Kimberly Clark's going to see that row within seconds. And so that's a big thing with Snowflake, is the ability to data share. And you can also replicate data to other clouds. So AC Nielsen actually has their database, primarily in Azure East, but they replicate to a bunch of the other Azure clusters around the world and a bunch of the other Amazon clusters. So I think currently they're in more than a dozen different Snowflake regions. And so they can share their data globally. And then one thing besides time travel is you can make a snapshot at the end of every quarter whenever you want and have a clone of your data that never goes away. And so finance companies like to have a month-end, quarter-end snapshot of their finance data in case they ever need to recreate their financial statements. And it's cheap to keep those. Why not be able to have them on? It's like time travel that lasts longer than 90 days. So any questions on this? I'll stop again and let everyone talk. Anyone fumbling for their mute button?
Yeah, I just want to confirm what you're saying as far as kind of like the sales and data science. So again, you're saying each one of them can kind of request their own compute, and that part's independent. So they're really not affecting each other.
Correct. Yeah, AT&T used 40,000 Snowflake servers in one day. And they had a bunch of different groups. Some of them were using big clusters, some were using small clusters. None of them had any impact on each other. And if you think about it, even on the storage side, Azure and Amazon take care of that. They've been serving, images for web pages for a long time. If there's a lot of demand for a file, instead of 3x replication where there's a copy in each data center on the campus, they start replicating it automatically or spreading it to different devices. So blob storage handles concurrency by spreading it to extra physical devices. So I've already seen Snowflake tables that were on, instead of just 3 different devices in Azure, sometimes 12 different devices to handle the concurrency. And that's nothing special about Snowflake, that's just Azure Blob Storage. Make sense?
Yep.
So that stuff is just happening behind the scenes. That's your management layer that's regulating the replication. And
no, that's actually Azure. Azure can just tell in Amazon if something's hitting blob storage and their devices are getting too busy. They've got processes that automatically copy it to other devices to relieve that congestion. And so that's all their brilliance that we're just benefiting from. Sometimes people, smart guys like yourselves who are DBAs, wonder why we don't have storage contention. It's because Azure and Amazon fix the storage contention automatically by making extra copies of the data. You start out with 3 copies of your table. If you hit those 3 copies hard, all of a sudden you're gonna have 6 copies. And you never even know, right? I mean, you don't pay for it. They just do that to make their system work better. So we've got really good security. I tell people, you know, a big table might have 10,000 blocks in it or micro partitions. We use a different key for every block, and we rotate that key every year and rewrite it every year. We re-encrypt the table again at the table level. So from now, here's 10,001 keys. We encrypt it again at the account level, 10,002 keys, and then we let you bring your own key to encrypt it so that you can scramble the whole table whenever you want by just revoking your own key. And when people hear that, they're like, wow, we're not quadruple encrypting our data and we're not rotating the keys every year. Capital One used to keep data in Snowflake and out in an Amazon data lake. And then they had this thing where they were in the papers because they had a data breach, and that data breach occurred in their Amazon data lake. And so they basically stopped putting customer data out in Amazon, and now it's only in Snowflake because it's more secure there. We don't make firewall mistakes. You know, we can't even see people's data. We're like your system DBAs where, you know, we can patch the system. If you make a Snowflake tech support case, you know, you don't need us to send us any logs. We've got the logs. Just tell us the query ID that you had a problem with, and we can take care of it. And a lot of times we fix bugs before you even see them because we're watching the logs and we've got a bunch of automated routines, you know, looking for failed queries. So security is a reason why people buy Snowflake, because it's usually better than what they've got today. Here's a neat POC we did with a company called UAL. And they said, hey, I want to see how this t-shirt size stuff works. I don't really believe it's scalable. So I've got 7 raw terabytes of data, and I'm going to try all your different t-shirt sizes. And at that time, we had 4 extra large was the biggest thing we did. And what they found was pretty cool. They said, it's going to cost $36 whether I use a small or a 4 extra large, but I can get it done in 5 minutes or 5 hours. And the CUNA guys found this too. They were loading a big Axiom data set, and it was taking over 12 hours, and they were using a 4-node medium. And I said, hey, fire up a 4 extra large and eat that thing quickly. And sure enough, it loaded in 8 minutes, and it cost the same. It actually was a little bit cheaper than loading on the smaller node. And so if you're doing something big, this is the beauty of Snowflake is, you know, you're just paying us $3 an hour per server, but it actually doesn't cost that much to use a 4 extra large for 8 minutes. You know, in this case, it costs $36 to use one for 5 minutes. Questions on that?
Have you seen a wide variation in that depending on the type of workload, its ability to split that?
I guess what I would say in Wisconsin, people are generally using small, mediums, and larges because their data is not that big. But my one customer, Komatsu, has a trillion row table, and they'll use 4 extra larges all the time on their trillion row table if they need to do something big quickly. Does that answer your question?
Yeah, I wasn't sure, because my understanding is there isn't any kind of explicit partitioning or anything, so that's kind of magical behind the scenes. Are there some workloads, you know, kind of your traditional, say, ELT or whatever, that lend themselves to better be that parallel processing, or are some things not able to kind of distribute that workload nicely?
I would say everything gets distributed okay. You know, we do our own micro partitioning. And if your data is sorted, or you want us to sort it, Komatsu's trillion row table is sorted by timestamp and machine ID. And so if they provide timestamp and machine ID in a where clause, they get a 2-second query, even on a trillion row table. There's 600,000 partitions. That query only has to look at 3 of them. Now, if they look at operator ID, generally, we keep a high and low value for every column in the table, for every partition. So immediately our cloud services brain says, okay, operator ID is in, say, 300,000 of the 600,000 blocks. And so we automatically know we don't have to look at half the table, but we still have to scan half the table. And what we've done to make it even better now is we allow you to turn on large table optimization, and we'll build a hash index on all the columns like operator ID that aren't well clustered. And Komatsu tried that, and they got there, instead of scanning 300,000 some blocks, they only had to scan, say, 1,000. And so we do have the ability to build an index, if you will, but you just have to say, hey, if the table's over 100 million rows, turn on large table optimization, and Snowflake will build a multi-column hash index. And so between sorting your data and using this large table optimization, you can always get fast results on big data.
Great, thank you.
Great Wolf Lodge sorts their big guest table by property and guest name, or guest ID, because that's the two queries that they use the most. So here's data sharing. We don't do any data movement. People get live access to your data if you want them to have live access to it. So companies like AC Nielsen, Experian, all the big data companies are starting to do this with Snowflake, because sending someone an FTP file is just like giving them a problem. And a lot of times the customers are excited now because they were getting data that was a month old by the time they loaded that FTP file. Now they're getting live access, so they can see updates that happened in the last hour instead of last month. A little bit about our Microsoft relationship. We're one of their largest customers. We're also a strong partner. The guys who sell Azure love us. 2/3 of my customers in Wisconsin are running on the Azure platform. But then if you're the guy that sells Azure SQL, DW, or Azure Synapse, we're a competitor and you probably don't like us. We plug right into the Microsoft ecosystem. Azure Data Factory, SSIS can load us. We're running on Azure Blob Storage using Azure VMs, and all the client side Power BI, Databricks tools work with us too. So basically on any Microsoft cloud infrastructure diagram that Microsoft comes to sell you, you can just replace Azure Synapse with Snowflake, and you're basically just saving money and having faster queries. And here's what Snowflake's bigger reason is. I mentioned that the Azures and Googles and Amazons, they're big companies and they kind of understand our architecture. It's going to take them a couple of years to copy it. But what they're not going to have is they're not going to be able to run on each other's compute. Azure's never going to run on all the Google and Amazon regions. And so this is what the world looks like to Snowflake. Snowflake everywhere. And then since we can replicate our data everywhere, companies like AC Nielsen and Experian are viewing this as a single Snowflake system. So they can share data with, they might start out in Azure East, but replicate their data to every region in the world, and they can share data with customers all over the world. Questions on that? That's our biggest benefit that nobody's going to be able to match, is this cross-cloud data sharing, transactionally consistent replication. A little bit about IoT. I talked about Komatsu. They've done some webinars for us. They've got 2,000 connected mining machines. They're long wall miners as big as a football field. They're getting 3,000 metrics, 50,000 times per minute. They're using open source plumbing, but I've got other customers using Microsoft's Event Hub and IoT Hub. Snowflake can eat that very easily. They're just using Snowpipe for some of the data, and they're inserting data with Spark for some of the other types of data. They're just trying to increase the efficiency of these machines. And so see this orange machine here, that's some ugly thing that goes underground and crunches up coal or whatever they're trying to do so they can mine it. If if that thing on the front breaks, that's a custom part built in Milwaukee, and that machine's down in Australia. That machine's going to be offline for a while, sometimes a month it would take to get a custom part to Australia. What they're doing right now is they've got vibration sensors where, much like your car, before you hear any alarm or get a dashboard light, your car starts making a funny noise or a funny vibration. And they're sending these parts before the machine breaks, just based on strange readings they're getting on vibration. And so they've been able to increase uptime in some of the mines for these machines by 40%, almost doubling the utilization. And all their customers want to see data sharing too. So these mining customers actually own the machines, and so they're saying, hey, I like getting these reports and alerts from you, but I want you to send me this data. Can you FTP it to me? And they're like, hey, I've got something better than that. I'm going to replicate my data to Azure Australia and share it with you, and all you need to do is get a Snowflake account, and you can use Power BI and Excel to your heart's delight. And so they're going to be sharing that trillion row table with customers in Australia, first replicating it there, and then just sharing it with a secure view. So every customer sees their own slice because the secure view filters on customer ID. So they only see their machines and their own data, basically their own subset of that trillion row table. Questions on that?
My understanding too there that I saw as one of the advantages is that that compute that they might use when sharing, you have the option of them using their own account where they're paying for the compute, but you would also be able to take on that cost and essentially share it with them. Is that accurate?
That's exactly right. If the mining company gets their own Snowflake account, they're paying the freight for the compute. And we actually give Komatsu a 10% rebate on data sharing compute. So Komatsu is making money off the data sharing with their customers. I mean, it looks like AC Nielsen's basically going to get free Snowflake because they're sharing data with so many people. And then if you have a customer that doesn't have Snowflake, you can instantly make them what we call a reader account. So they'd have their own unique Snowflake account, but you would be paying for it. So it'd be part of your Snowflake organization. You can have multiple accounts in Snowflake, and you can automatically create an account for any customer. And so effectively you're paying the freight for them, and then you're a little bit like a drug dealer. We find that people that get reader accounts quickly want their own Snowflake account to get their own data in there as well. Make sense?
Yep.
And then here's the kind of thing we're doing at a refrigerator manufacturer. And I made this, I anonymized this, but they've got a big JSON packet coming in, and this one's for a refrigerator. The header's got some appliance information, and then there's a bunch of water filter, purifier, condenser, dispenser readings. And I mentioned that they can just put this all into one table. And I can see, how many times they're opening the door, is the air purifier out of date, when did they last change that, et cetera. And what we're doing is we're just creating a view. So this is kind of the Snowflake JSON specific syntax we're using. We're using a lateral flatten. We're doing a lateral join of the header to each packet. We're flattening each packet. And then this one's a water filter view where I'm saying, hey, I want to see appliance series 1, which is the refrigerator, and only pick out those JSON packets with record type 4, which was the water filter one. And then the view, I've got some of the header information, and I've got the water filter information, which really they just wanted to see water filter life. And so I never had to mess around with ETL tools on this. I was able to basically load millions of JSON rows into one column in Snowflake and create a bunch of views that made it look like I built it into a data warehouse without ever doing anything. Questions on this? We can do this with XML. Insurance companies give me their ugly XML package extracts in XML. We're able to build views on those. If you have Parquet or Avro from Hadoop, we can build these kind of views with that too. Basically anything that's got a tag and a value, semi-structured data.
You mentioned that Databricks can run against it. Are there scenarios where you kind of hit the limitations of this and choose to do some sort of transformation with Databricks?
No, we generally can transform this. Once we flatten it, if I just see create table as, select on this view, it's flattened. We do have customers using Databricks, and they tend to be doing Databricks for machine learning or more complicated programming than we can do, say, in a SQL stored procedure. And we've got external functions, where we can call Databricks scoring routines. So I've got some customers using that. We're talking about putting Spark in Snowflake, so you could also fire up Spark instances, because we do find that a lot of our customers like using both Spark and Snowflake together. So I'm hoping we come out with a Snow Spark next year, but right now we have to partner with Databricks, and I would say the problem with them is they're starting to try to do data warehousing too. So it's hard for us to all be friends when we're trying to steal each other's money. But that's how it is, life in the software world. And so that's the end of my presentation. I'll take any questions, or people can drop off, and have a good evening.
So I'm curious of, say, multi-tenant scenarios. So if you are a company and you're hosting data for many clients, in something like that, certainly, this infinitely scalable notion, if you were bringing data in from all these various clients, would you simply be putting them into kind of a single table and you would just rely on Snowflake to kind of partition that in a certain way, or do you still implement kind of partitioning, I guess, logical in how you organize your data model?
Yeah, most of my customers have one table. They create what we call a secure view on that table, and each customer will get their secure view, and they just order the table, usually by timestamp and some other main key field. And we've got an automatic cluster, and we can automatically keep that table in that order for you. If you do specify a cluster key to us, you're telling us you want us to keep the table in that order. Otherwise, you can just do an order by, create table as, select star from table, order by the columns, and fix it every now and then yourself. The Great Wolf Lodge guys recreate their table. Basically, they reorder their table once a month, because the data they ingest comes in the wrong order. So every now and then they just reorder it. And that's really the only tuning you need to do in Snowflake, is sort the data in your biggest table. You partition everything. If you've got a really giant table, you can turn on that large table optimization. But we're trying to keep it simple, right? Mm-hmm. We want DBAs to be application DBAs, not system DBAs.
So in that scenario, I guess if you had a single schema, say a multi-tenant application, if I only have 10 tables in my app, I could get by with truly 10 tables. And then I would simply, if I have 100 customers, each of them would be using those exact same 10 tables, and I could ultimately create client-specific views for each of them that would only see their own subset.
Exactly. And that's how people are doing it. That's how Komatsu's doing it. Johnson Controls, with their building energy management system, is planning on doing it that way too.
So, and other people can chime in with questions at any point, but I'm curious as well, your experience, Power BI is something I incorporate a lot into solutions, and it kind of has its own built-in tabular model, which is similar to the Azure Analysis Services or SQL Analysis Services model. And that is itself, I know, a column store very similar to Snowflake. I'm just curious how you've compared that to the modeling you would do in Snowflake when working with Power BI, from a performance, usage, any other considerations?
Yeah, it's a good question. I mean, Power BI, I would say, is the #1 BI tool in Wisconsin. Tableau is second, so we've got a lot of Power BI users. Snowflake is kind to different data models. Like I happen to like star schemas. I also like, denormalizing, putting dimensions in the fact. Since we're a columnar database, you can have repeating values and that doesn't take up any space and it doesn't hurt performance. So in short, you can build a really ugly data model in Snowflake that wouldn't work well in SQL Server, and it's going to work just fine in Snowflake. So it's hard to do something wrong in Snowflake. But good data modeling, if you're data modeling for performance and not to save space, star schemas always work great in Snowflake. But a lot of the data modeling I've done was kind of arbitrary to create performance. I was trying to get rid of repeating columns, repeating values in columns. Don't need to bother with that here. Actually, if you do some denormalization to reduce your joins, that'll make Snowflake a little faster. And nothing specific with Power BI. You're going to make all BI tools faster because they're all just running SQL. With Power BI, people tend to do direct query. Most of our customers don't pull the data back to Power BI and let Power BI join different data sets. They set up Power BI to push as much to Snowflake as possible.
This is Jason. I have a more specific question for Power BI. So we have multiple roles for users, for example, and as you know, for example, if we have a marketing role and customer service role, they need to switch roles. The user needs to switch roles to see that different data. So with Power BI, you can't set the role that it passes to run as, and by default, it's just going to use the default role. If you had a workaround for that, I know it's supposed to be coming for Power BI, but it's not.
It's supposed to be coming
yet.
next month. I just got a note from our ecosystem guy. He said that role selection in Power BI is supposed to be coming soon. Although next month for Microsoft, what I've noticed is that they're slow to put Snowflake features into Power BI, and it could be because they've got kind of a home field advantage for their own databases. But it is actively being worked on by Microsoft. So that's what you're effectively asking about is a Microsoft feature that
Right.
more fun to use with Snowflake.
Yep. Yeah, it definitely is a Microsoft problem. But I guess I was curious if you have a workaround that you've seen other customers use. Like, are they using default accounts or just hard-coded accounts that are accessing the data, or are they manually changing the default role through some other means? Or are you just creating roles that are kind of like super roles that they have access to both areas?
Yeah, I guess I don't have a good answer for that. I'd have to think about that. I can think about that and get back to you.
Sounds good.
It's easy for me to just make something up, but since I like you, I'm going to give you a better answer. You're a Snowflake customer.
True statement.
Yeah. Other questions?
So the Snowflake, with this being a software as a service solution, this is everything is just running in your tenant, right? So I wouldn't have like a Snowflake resource in my tenant, in my Azure tenant, and we would just add some sort of a VNet integration or something like that into yours.
Yeah, well, if you think about it, at a high level, you don't even need your own VNet to use Snowflake. Like I have customers running us on Azure that don't even have an Azure account. They can set up blob storage buckets we call stages, load their data into that, they're all good.
But the blob storage.
But if you do have data, say in blob storage, you can just set up a storage integration and we can talk directly to your blob storage because your blob storage isn't inside your VNet. We can do integration, to your VNet, where if you've got an application running in your VNet that wants to run Snowflake, Snowflake queries, that works fine. You can set up a proxy in your VNet to make sure you always run it through your own express route to make sure you're using your dedicated network and not going to Snowflake directly. But there's not a lot of worry with your VNet. And the reason you're running in our VNet is we need to be the system DBAs for this thing, right? We need to see the logs, we need to control it. We do have what we call private Snowflake, where we give customers like Capital One their own VNet, but we're controlling it. At least they know, they like that it's not a multi-tenant VNet. The benefit of being in a multi-tenant VNet is it's a lot easier to get compute. There's, you can fire up a 512 node Snowflake cluster very quickly. In private Snowflake, that takes a little longer. But we mentioned to them that that's going to be the trade-off.
Sure. But it sounds like, so if I already have my Azure tenant with a whole bunch of resources there, including just the Azure SQL database, and a couple blob storages, maybe the storage accounts, you're able to just make Snowflake from your tenant be able to talk directly to the storage account and my tenant, because it's all inside Azure anyway.
Yeah. And I guess the key is blob storage is really horizontal. It's not in either of our tenants, but our tenants have keys to it.
Yep.
And so all you have to do is give me the key to your blob storage. Like if you just give me a SaaS access key, I can create an external table that reads your blob storage.
Interesting.
No VNet firewalls, no nothing. So the integration is pretty easy really with Azure. And we're selling to some big companies where we're pretty tightly integrated in with their Azures. Like, they like the idea of us being able to create external tables that automatically look at their Azure storage or external stages, loading buckets that reference their data lake. But we don't really need to get into their VNet, and they're just talking our VNet on port 443.
Sure. Okay.
I have a bigger problem with like insurance companies where they have a proxy on-prem that automatically blocks everything. And, we need a signed certificate to come down to the browser, and they like to either block our certificate or replace it. And so I usually need to get a proxy exception for the on-prem, like blue coat proxy servers, one vendor that blocks us. But in the cloud, there's usually not much problem with integration. Other questions? Here's another thing. I say try it and you'll like it. You can sign up for a Snowflake account at trial.snowflake.com. We give you $400 worth of credit and we give you 30 days. And we share a bunch of really large tables with you. We share multiple versions of the TPCDS and TPCH benchmark tables. And so we share with you a 10 terabyte TPCDS database. There's a 28 billion row store sales fact table in that database. Like before I came to work here, I got my own Snowflake trial, even though I was working at Cloudera. And I was familiar with TPCDS benchmarking. And so I'm like, holy crap, they've got a 28 billion row fact table out here they're sharing with me. Like to this day, that's the biggest table I've ever heard. And so I got to try out Snowflake on big tables with $400 for free before I ever came to work here. And I figured out right away it was beating the pants off our Cloudera Impala because I'd done some TPCDS benchmarking with that. So I would encourage you guys, if you want to learn more about Snowflake, send me an email. We've got a nice tutorial that takes about 60 minutes to go through. We've already got data staged up in the cloud for you. Very easy to load your data in your trial account. And when people finish this 60-minute tutorial, a lot of times they tell me that took care of 20% of their POC requirements. Like they had a list of stuff they wanted to see in the Snowflake. Our 1 hour tutorial does a quarter of their POC for them. And so we'll help set you up with a Snowflake account and let you try our tutorial. And that's really how people start with Snowflake, just like Century Insurance. Used it for 6 months without us knowing.
Hey, Brian, when they do trial accounts, do they get access to the data marketplace?
That's a good question. I think they do.
Okay.
See, I don't see why not. Every Snowflake account is a real production Snowflake account.
Yeah, good point. Yeah, so one of the other cool things for those that are, into data exploration, we had some publicity back in April where we got together with kind of a COVID alliance, a bunch of technology companies, government agencies, hospital care centers, et cetera. And we built out on top of the Johns Hopkins data set, but it was more curated and updated in a more ETL'd format. So all that is out in our marketplace, and I know like Lang Exact Sciences folks are using it for internal purposes. We've had retailers that have been using that data set in our marketplace to try to predict out quarter like foot traffic and revenue that's coming back into retail stores like a CVS or a Walgreens. So there's really cool stuff. You know, there's the benchmark database that Brian mentions. And if you have additional credits left over, you know, go out, look at the marketplace, see if there's some cool data that you could explore with and play with. And there's no shortage of ideas and options out there for you.
Well, that's good to know.
Very good. Brigitte, you know, again, you know, I wanted to just kind of thank you personally, you know, for inviting us here. Obviously, we appreciate being a part of the, you know, the local community. Both Brian and I are Madison guys. I'm an East, he's a West Sider. So the infighting continues. But, you know, we appreciate the opportunity to speak with you. You know, it's good to speak with some